Alright, welcome back. We are starting with the first exit ticket. So it's Q3 week 1. On your paper it should say week 1 SIN 503. So for SIN, that's scientific investigation. This is our lowest performing standard on the interim. I'm going to flip straight to the questions. So based on study 1, if the driver of vehicle C wished to stop in under 10 meters and the friction between the road and tires was 0.6, she should be driving at a velocity of. So you need to look at what you're looking for. So this whole standard, the steps here, first one is read the question. Second is highlight every variable in the question. The third one, you're going to go back to the table or figure and highlight those exact same variables. And then you're going to look for your answer. So it's really only 3 steps that you have to go through. So based on study 1, I'm going to go to study 1. I'm going to put a box around that one. If the driver of vehicle C, so I'm going to go down to vehicle and I'm going to circle vehicle C, wish to stop in under 10 meters. Stop, I need to know the stopping distance. So that's the first line of this passage. So I'm going to look at D. In under 10 meters, so right here, this was 11, that's our closest to 10, and a coefficient of friction was 0.6, so I'm going to look at the 0.6 and the 11, not the 0.3 and 21.6. Then my velocities, I need to go to this table, so it's at 40, so that means that this needs to be less than 40 because that was already too high. That's how you answer the second question. Our first question. So number 2, based on study 2, so I'm going to go into study 2. Which tire type and road condition would need to be used to achieve a friction closest to 1.1? So tire type and road condition, which means I'm looking at these 2 columns on my table, and friction closest to 1.1. So I have a 1.43 and I have a 0.89, but this 1.143 is a lot closer. And if I look there, that's dry and racing. So racing tires on dry road. And you match it to there. So this standard is actually 2 questions on your interim, and it should be a lot more simple than SIN 501. Number 3, according to the data provided by the 3 studies, to minimize stopping distance, vehicles should be driven. So we need to look at all 3 studies, and I need to figure out what can minimize the stopping distance. So which here has the smallest stopping distance? So in this study it's 16.9, but this does not tell me anything here. So let's see, so it's 16.9, dry, CIP of 140. Let's see, the smallest stopping distance here is 12.4, dry, racing tire. Let's see if we can get a smaller stopping distance than 12.4. I have 10.8, 10.8. Those are the 2 smallest, so that was 1650, 1100, velocity of 40, velocity of 40. So let's see what we have there. We don't talk about tire pressure. We do have the velocity. We knew that dry roads were better. Only if their mass exceeds 1650. We wanted smaller than that. So the answer to 3 is D, because the 2 smallest distances were also at the 2 smallest speeds. Number 4, based on study 2, if a stunt driver wished to maximize his vehicle's stopping distance, so maximize, he would perform his stunt. I'm only going to look at table 2 because it's study 2. So study 2, maximize the stopping distance. Which one of these numbers is the highest? The highest stopping distance for question number 4 is at 48.3, and what are the conditions? He has racing tires on can't talk today. He has racing tires on a wet road. So racing tires, so I can cross off A and B, and then a wet road. The answer to number 4 is C. And remember, when 2 answers are almost the same, almost identical, it's between those 2. So you pick one. So C and D, the only difference is that one says wet and one says dry. And last one for Do Know number 1. Question number 5. A driver using racing tires and traveling at a speed of 60 kilometers per hour wishes to decrease the wet road stopping distance to 40. Which of the following friction values would most likely achieve the desired stopping distance? So I need to go to somewhere where it talks about racing tires, and the only one that it does that is in study 2. So study 2, I have 2 racing ones, and then it's a speed of 60, and we want it to be about 40. So I have 12.4 and 48.3. And the friction needs to be somewhere between these two. So that's 0.293 and 1.143. Let's see if we get any information here. And then 60 kilometers is in between the two speeds we studied, 40 and 80. So the friction value just has to be between these ones. What value would most likely achieve the desired stopping distance? 0.21 is too small. 0.293 is one of the values. 0.626 and 0.354. So for this one, we have 48.3 and 12.4. 40 falls closer to which value? 48 or 12? So in your head, if you were saying that it was closer to 48, that means that the friction is also going to be closer to the 0.293 value, so the answer to number 5 is C. This one is actually a combination of IOD 404 and SIN 503. So you're predicting the results, but this one you also had to interpolate from the variables.